Let's write our base screen handler abstract class. Hello everyone, this is Andy Reza. Welcome to the Mentor Code Lab. Now, what is a screen handler? When you have a user interface, there are two sections related to that user interface for a block entity. One is a class that is responsible of rendering the interface on the screen, and the other one is a class that is responsible of providing the information needed for rendering. These two are dissected in Minecraft because the class that is responsible of gathering the information sits inside the server and the client. However, the rendering part is only client side. The class that is responsible of collecting the information is called handler. And in this video, we want to write an abstract class as a base for every screen handler that we will use. Now, here's the thing. I have implemented my own way of having an abstract screen handler before, and I noticed that Turtiworty had done his own version. However, what Turtiworty had done is combining everything inside one big composition. For example, he has a wrapped inventory storage and the holder. And these are not what I want here. For example, the property delegate. I don't want it here because the idea of this base is that it should be something that contains nothing else but the very basic boilerplate of a screen handler. For example, caching the block entity, caching the context, caching the player inventory if we need to, and stuff like that. So the word, the block, and no inventories, because honestly, we don't know if we want to bother ourselves with any extra inventories or property delegates. Those are related to machines or crafting, and they are not happening in this library. We have another library for the inventory, another library for the machines. So this base will be used on top, or I may totally ignore this base and add my own stuff on top as we go forward. But what we have here is an abstract screen handler. Now, I am debating on using it this way as I had done, or go with the way that Turti had done it, because he is using generics to typecast this block entity, and also the same thing for the payload. However, this is a position payload, so we have a dedicated payload for that. This thing, however, is a little bit different. The wrapped inventory storage holder is an interface that returns a wrapped inventory storage, and that is get wrapped inventory storage. So let me do it this way. I will go for a combo if I can. If I can't, then I will just have another class completely for itself. So I will say t extends. Now, do I want a block entity, or do I want any one of my own base stuff? If I go with block entity, that's more generic. So I think I will keep it as block entity. And then we don't want to typecast the P. And now it should be extending the screen handler. Because of that, now we have to implement methods like quick move and can use. And also we have to create a constructor. Now this constructor will be changed, but before that, I want few different things. For example, protected, that is final T block entity, a protected final screen handler context. We call it context. I'm looking at the Turtiworty solution right now. I'm not gonna add a wrapped inventory storage or a property delegate right now. As I said, this is the minimum things that we need. However, I will add the word protected final word. We call it word protected final block. And I think that's it, because having the word and having the block entity, I have the position of the block entity and I can have the block, but I want to make things easier for myself. So let's take a look at the constructors that Turti had done it. He asked for the type, sync ID, player inventory, the payload, and block entity all in one go. Then he has another one that accepts property size. Now this one is for the property delegates. I don't want that. He has one that accepts wrapped inventories. We don't want that. Let's start with this. We say public abstract screen handler. This will accept a screen handler type of unknown. We call it type. An integer, we call it sync ID. Then a player inventory, we call it player inventory. By the way, I can keep that if I want to. I will keep that. So protected final player inventory. And then the payload. Now for the payload, what he has done is that he introduced another interface, has position payload. And of course, this is block pause. I'm not going to do that. I will directly accept the block pause payload, and we call it payload. And then he is asking for block entity class as the T. So class of T, this is block entity class. class. What he's doing is interesting. He's caching the block entity type or class, I should say. Okay, so he has something that I will add. He'll say this, the type, the sync ID. Actually, that's the sync ID. This is the property size. We don't need that. The sync ID, then the player inventory, then the payload, then the new something that we don't have. Cached block entity of generics with the block entity class. Now we need this overload. So I will copy that. I will paste it, and we say the last parameter is not the class itself, it's the cached block entity of type T, and we call it cached BE. Now, he is calling another overload that accepts the sync ID, player inventory, then wait a minute, this thing is a little bit confusing. Apply returns T, okay, that returns the block entity, okay. So he's doing it this way. What he's doing is that he's sending the block entity and then wrapped inventory storage and property delegates. So block entity, wrapped inventory storage, and property delegates. So he's going for this overload. I will take this part, and by the way, this is how you can use someone else's code, and this is abstract screen handler. Okay, that is that. So here we call this with the type, with the sync ID, and why am I not seeing it? It should be lowercase s. Okay, then the player inventory, and finally from cached block entity, he says cached be.apply for the player inventory and the payload.pos. Okay, finally here he calls the super with the type and the sync ID, so that frees us from this overload. Then we say if the actually properties is the delegate properties, so we don't have that. He says this dot context, both of us had this one, screen handler context dot create from player inventory dot player dot get world, comma block entity dot get pos. Okay, now this part I will use it, and I will say this dot world equals to world, and here I will use this dot world. Okay, that's two lowercase s, please. Okay, what is wrong here? No, I don't need add constructor parameter. Okay, the player inventory, of course, this dot player inventory equals to player inventory. This dot block. Now I'm switching back to my own code here, equals to this dot world dot get block state at this dot block entity dot get pos, and again I will cut this dot block entity equals to this, and finally I will get it here, I will paste it here. What's wrong with you? It says replace with qualifier. Oh yeah, okay, dot get pos. So what's wrong here now is that at the end we need the get block. Okay, then we have few different ways of handling things here. He calls add block entity slots for the player inventory. I call add the slots for the player inventory. So add the slots for the player inventory, and then add, actually I think he managed it all in one go. Let me double check. Interestingly enough, add player inventory, add player slots. Actually we have it now. Okay, player inventory, get player inventory X, get player inventory Y. We both had this, in funny enough. And finally, he is adding a call for the wrapper storage. We don't have the wrapper storage right now. Now, to show you my solution, I had these inventories as simple inventories, and I was calling the unopen here, but I had this, and instead of calling the slots and hotbars, now we have the add player slots in one go. I hope that adds the hotbar, isn't it? Add player inventory and hotbar. Yeah, so it's doing it in one go. And we both had these concepts of player slot X and player slot Y, and he calls it inventory X and inventory Y. That's okay. I was calling add the slots without accepting player inventory. He is sending in player inventory. So both are thinking the same way. His quick move is a little bit better constructed compared to mine, but mine is better named compared to him. So we ask for a new stack, and that is empty. Then we accept a slot, and that is the slot that we sent in. Let's call it the slot index. His naming is much better than mine. Okay, so after this we are checking if the slot actually has a stack. If that is the case, we return the new stack. Otherwise, we continue on handling the movement between the shift clicking. We say that we want the stack that we already have in the slot, and we want to copy it to our new stack. Then we say, actually, wait a minute. Oh, here we go. Now we need the inventory size, and the inventory is a problem here because, as you see, actually, that's fun. That's nice. That's nice. We can do that, yeah. So we say if the slot index is smaller than get the inventory size. So if we are smaller than inventory, we are doing something, and otherwise we are doing another thing. In this scenario, we say if not insert item from stack in slot to this dot slots dot size minus 9, comma this dot slots dot size, means that we are clicking from our hotbar to our other inventories. And finally, the last parameter is from last, we say true. If we didn't success this way, we want to reverse it. So if not insert item from stack in a slot, but this dot slots dot size minus 36 into this dot slots dot size minus 9, and again here we say false. So this time I think we are clicking from the block entity inventory to our inventory until we get into the hotbar. I'm not sure about that, but I think that's the case. If none of that worked, then return item stack dot empty. We can't move anything, and of course we can get rid of these square brackets. Now otherwise, if the slot index is greater than index of the inventory, we want to say if not insert item the stack in slot, we start from 0, we go to get inventory size, and we false. If we fail, again we return item stack dot empty. Now let me review. If we are smaller than inventory size, means that we are clicking in the inventory of the block entity. So if that's the case, we are trying to put it in the hotbar. If we can't put it in the hotbar, we try to put it in the player inventory. If we fail, then we do nothing. Otherwise means that, hey, we are clicking somewhere in player's inventory, maybe hotbar, maybe the player inventory. We will try to move them to the block entity. Okay. At the end, we do two different things. We say if stack in slot that is empty, then we say slot, or here is the new slot, new stack. Actually, wait. The slot. No, we have that. The slot dot set stack to item stack dot empty means that for some reason we moved something from this slot, so we should empty it out. Else, we just make the slot dirty so that it updates itself. At the very end, we return the new stack, and that's it. So his way of implementing is nicer than what I did. Let's do a comparison here. First of all, I'm using the inventory.size. So I'm hard coding myself to have an inventory here. However, normally you may not have an inventory. Maybe you're a battery bank. So when you are opening the battery, there is no slots there. There is no inventory in the GUI, at least for the block entity. All you have is an energy storage, for example, or it's a fluid tank. So there is nothing as an input or output slot there. Having this means that I'm focusing on the inventories and the interfaces that has inventory. The way he had done it is that he is implementing a method, and this method can return 0. So that's that. And then the rest is mine is not complete, as you see. I'm just trying to insert from original stack into the inventory, from the inventory into the slots, and that's it. And I had a little bit of problem doing it this way beforehand. And if I can't, then I do the reverse. These sections are okay. His implementation is more flexible, more complete, and more logical. Okay, now we have the unclose, but he is using unclose for the wrapped inventory storage. We don't have the inventory storage yet. Now we have the can use. Again, his implementation is more complete compared to me. So I really want to, or I should say, I really should copy this and paste it on top, because I really added few different things and removed few different things. But the main logic belongs to Turtivorti. So here we say a Boolean valid block equals to false. Then we say for each block, we call it block, inside the get valid blocks. Now this is another method that we should write. For each block inside valid blocks, we say if can use this dot context comma player comma block. We do two things. We say valid block equals to true, and we break out of the loop. And finally, at the very end, we return the valid block. Now what I did was just using this return can use this context player. It is negating the fact that we can validate the blocks. So we have a block entity. The block entity is protected, and we may want to have a getter for it. So public that returns t get, actually we call it block entity, and yeah, get block entity, that makes more sense. Here we return this dot block entity. Then we have that validate block, so protected list of block, and that is get valid blocks. For time being, we return an empty list, so list dot of. Then we have that protected int get player x, we return 8. And honestly, I think I will make it abstract so that we don't need need to write those and make it, oh no, that's the getter for block entity, what I'm doing. This guy. This, I want to make it abstract. That's that, and the class itself should be abstract. But wait a minute, what's the problem here? Add constructor parameter variable might not have been initialized. Okay, let's make it abstract. I'm not sure about these. Why are you not happy? Isn't this calling this one? Oh, we didn't add this class yet, so let's do it and we will understand later. Another one, protected abstract, that returns int get inventory y. Now, he has a hard-coded number here as 84. I will not do that. I want to force everyone to each time they send back the number. So protected abstract int get inventory size, and that's it. And let's put them on top in order. Finally, we have that add block entity slots, but I call them add slots. So that's another protected abstract void add slots that accepts a player inventory. Okay, now the remaining thing is to add this cached block entity. He had put it as an internal class. Wrapped inventory storage holder implements by function, blah, blah, blah. All he's doing is not even using it, okay? So all I want to do is put it somewhere, but I'm not sure if I should put it on client or on block entity. Do I want to use it server side? What he's doing is actually retrieving the block entity from the class type. So let's see, it has a class, it has a map as a cached one. When he's sending in the class, he says this block entity class is equals to the class. And when he's applying, he's checking if he has the block entity being cached before, then so be it. If not, he asks for the block entity and he checks if the class is the same as the block entity. He casts the class for the block entity. He puts it inside the cache and returns. This is a static class that can be used anywhere. And actually, it looks like a utility to me, but it belongs to block entity and it's not a block entity itself. So I will put it under utils, new Java class, and the Java class is called cached block entity. And I will dissect it because we are just using block entity and not the wrapped inventory storage holder. It implements the by function of player inventory, not info inventory, and block pose with that type T. So it says implement the method, apply, yes. Then on top, we will have a private final class of the type, and we call it block B class for short. Private things are not important. So as the naming goes, final map. By the way, don't get me wrong. If I say the naming doesn't matter, it means that you can name whatever you want, but you should understand what you are naming them. It doesn't matter if I call it block entity class or class of BE or class of block entity or BE class. All that matters is that I understand what's going on there. So it's a block pose and T. This is our cache equals to new hash map. Then we have a constructor that accepts the class. Now here, BE class, that's okay. In the apply, we check if the cache dot contains the key for the position, for the block pose. If that's the case, we return the cache dot get the block pose. If we don't have it, then we say block entity, and we call it block entity equals to player inventory dot player dot get word dot get block entity at the block pose. If BE class dot is instance of the block entity, we want to do things, else we want to throw. So throw new illegal argument exception, and here we send in a message block entity at plus block pause plus space is not of type space plus B class dot get simple name. Now if we are the instance, we say T casted BE equals to BE class dot cast the block entity. This line casts the block entity to the class type that we sent in. Then we say cache dot put for the position the casted BE, and I forgot that we already renamed this guy. Finally, we return the casted BE, and that's it. All this class is doing is just caching our block entities related to positions. Where do we want to call this guy? I mean, you're checking if we have it. If we don't have it, we are putting it there. But all we are doing now is just retrieving it inside here. By calling the apply here, we make sure that we have it inside the cache. What we are doing is actually making instances of this library. Each screen will have its own cache of the block entities. I don't like that. However, there is no other way, or actually there is another way of converting this to a helper method, isn't there? Because what we want is a class TBE class and a bifunctional of course, bifunctional will bother us. Java util function, tree function. Oh yeah, we have a tree function. And if we want to do that, we would go with player inventory, the block pose, the class of t, and then the t. And if we do that, we can implement the apply. Yeah, there we go. If we make this static, will we get a problem? Okay, that's not funny. Oh well, I think I will go with what Turtywurty had done. Honestly, this is a little bit of overkill in my eyes because you know what? We just want the block entity, and all he's doing is that he's trying to cache that block entity in memory so that after the first time he is opening the GUI, the next times he can retrieve the block entity faster. I really don't know because in my opinion, it's overkill. Honestly, it is a seriously overkill one. So all I can do is just have this, and instead of having the cached block entity, I will use this. And here directly I will send in the block entity, just like that. Now, why would I actually no, wait. I can do this. Player inventory.player.getWord.get block entity at payload.pass. So that's the block entity. And why are you yelling at me? It's asking for a block entity, not T. The way he had done it has an extra benefit, and that is that he knows the type of the block entity. It means that he will have direct access to every public method on that block entity if the method is specific for that block entity. The way I'm doing it is that if I remove that generic and use block entity, I have to typecast to my own types, and that opens the door to problems like improper casting and stuff like that. So I will keep it as it is. He's a smart guy. I agree that he is really smart. That's our base abstract screen handler. Now, in my own library previously, I had this abstract crafting screen handler. Now, the difference was that in here, I have this progress index and max progress index and the property delegate. And you see that it extends this one. The thing is that without having any inventory, crafting is impossible. So I will keep these and I will move them later to the machine library because at that time we will have access to inventories, we will have access to property delegates, and I will do that there. All I'm doing here is that adding a property delegate. As you see, get the progress index, for example, max progress index is crafting, for example, and get progress, things that he didn't have, but I think is useful somehow. Although I remember that he has a widget for the energy. I'm not sure if we may convert these to widgets. Anyway, the crafting screen handler remains to be put inside another library. And by this, we have only two more classes to add. One is info area. Now, info area is an extension of draw context. And honestly, these are small, so I will add them right in this video and get done with this library. So we have info area, and this is an extension of draw context. We have the constructor, but before that we have a protected final rect to I, means two integers, as the area. Now info area, we have the client and vertex consumer. Here we say this.area equals in new rect I for x, y, width, and height. We all use zeros. And then we will have another constructor. So add a constructor that accepts the rect area. Finally, we call public void draw. And this is draw context, anything. And I will call it abstract. And this class, actually, no, not call it abstract because this class, should it be abstract? I'm not sure, but the method is empty. That's the whole point. So the last one is a mouse helper. Now I would put the mouse helper under utils, but servers don't understand the mouse. Because of that, I will put it under the client mouse helper. And this one has a public static boolean is mouse over a double mouse x, a double mouse y, an integer for x, an integer for y, an integer for width, an integer for height, an integer for offset x, and an integer for offset y. Here, let me copy paste it because it's really easy. We just check that the mouse x is smaller than the offset plus width and is greater than the offset, and same things for the mouse y. So we are checking if the mouse is in the boundary of x and y plus plus the offsets plus the width and height. Then we have an overload for this that doesn't provide any offset. So it has only the X and Y. And for this, we return the call for ourselves is mouse over for the mouse X. And I did call it with two V's. For the mouse X, mouse Y, then the X, then the Y. For the width, we use the default 16 by 16 for the slots and no offsets. Now we have an overload of this and we use an integer as the size and we assume that the width and height is a square. So we send in the size and finally an override on the same thing, but we add the width and height. So without offsets. Now, of course, if I have an info area, I can do the check for the mouse overs here and I can use that rect. So I will add an overload here. Public static is mouse over with the, that returns a boolean, with the double mouse X, a double mouse Y, and then a rect that I can use. So I will return is mouse over for the mouse X, mouse Y, the rect dot get X, rect dot get Y, rect dot get width, and rect dot get height. And that's it. Rect doesn't provide any offsets, so that's that. Now I can ask for a mouse over. So I can say public boolean is mouse over, and all I need is a double mouse X, a double mouse Y, and all I'm doing here is that I will say return mouse helper that is mouse over with the mouse X, with the mouse Y, and this dot area, and that will cover this one. Honestly, that's all the things that we can add to this library so far, and by doing that, I think the library is finished and we can publish it to the Maven. Just make sure that the version is okay. Yes, we will publish it in Maven and we will go back to our main mod in the next video to make sure that we can use it. If you like these videos, please subscribe to the channel, hit the like button and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.